Good afternoon, my dear students. This will be the part 1 of our discussions in the intermolecular forces of the attractions. Okay, so in this video, you are going to learn what we mean by intermolecular forces of attractions, and there are three types or the common types of intermolecular forces of attractions, and the difference between these three types of intermolecular forces. An intermolecular forces is simply an attractive forces between the neighboring molecules. Okay, so there are three types or the common types of intermolecular forces of attractions. Okay, so the first one, we have the permanent dipole-dipole, hydrogen bonds, and the third one is the van der Waals forces of attractions. All of these forces are very much weaker than ionic or the covalent bonds, which bind atoms and ions together in an elements and a compounds. We have a video in each ionic and the covalent bonds if you haven't learned about them yet. Let us know. Look at these three intermolecular forces one by one. First, the permanent dipole-dipole forces. A polar molecules is one in which there is a permanent dipole arising. Usually, because the different atoms in the molecules have different electronegativity, is the attractions by a bonded atom for the pair of electrons in a covalent bond. Let us take the hydrogen chloride as an example. Hydrogen chloride is a polar molecule, as the pair of electrons in the hydrogen chlorine bond are nearer to the chlorine atom. In other words, they tend to one pole. The chlorine atom has a stronger attraction to the electrons because it has a greater electronegativity than the hydrogen atom. We can represent the hydrogen chloride molecules as H delta positive and the Cl delta negative. There will be the attractions between the delta negative on the chlorine atom of one molecules and the delta positive on the hydrogen atom of a neighboring molecules. Okay, so that diagram shows the permanent dipole-dipole forces between the two molecules of hydrogen chloride indicated here by the red dashed line. Okay, so the second one of intermolecular forces is the hydrogen bond. The permanent dipole in a covalent bond between the hydrogen atom and the fluoride oxygen or the nitrogen atom is particularly strong. The attraction between the electron deficient each delta positive of one molecules and the lone pair of electrons of a fluoride oxygen or the nitrogen atom of another molecule is much stronger than the permanent dipole-dipole attractions mentioned before between the two hydrogen chloride molecules. This particular type of dipole-dipole attractions between the electron deficient H delta positive of one molecules and the lone pair of electrons and the fluoride oxygen or the nitrogen atom of another molecules is given this special name of a hydrogen bond. So a hydrogen bond is the attractions between the H delta positive of one molecules and the H delta positive or negative rather on the lone pair of a fluoride oxygen on the nitrogen atom of a neighboring molecules. Even though a hydrogen bond has only 5% the strength of the covalent bond, it has a significant effect on the physical properties of a compound. For example, were not for the hydrogen bonds, both water and alcohol would be gases at room temperature. Number 3 is the van der Waals forces of the attractions. Firstly, now the spelling of van der Waals forces is the lowercase v in van, and the apostrophe comes after the s involves van der Waals forces are induced dipole-dipole interactions. Let's look at how this arise. I need you to have the movement of electrons in the shells. If we could freeze the actions of any moment in time, there would be an instantaneous dipole at that particular moment. These induced dipole-dipole interactions called the van der Waals forces occur in all molecules, whether apolar or not. But there are only intermolecular forces between the nonpolar molecules such as the halogens and the noble gas. As the number of electrons in the molecule increases, so the van der Waals forces. This explains why there is an increase in the boiling point as we go down to the group of halogens and the noble gas. The group of noble gas, so to recap, the intermolecular forces is simply the attractive forces between the neighboring molecules. The three intermolecular, the hydrogen bonds exist between the hydrogen bonds atom in one molecule.